we're going to talk about your special case triangles when you have side-side angle. Now, I guess before we start kind of looking through this chart here a little bit, let me show you what can happen here if you make a specific case of side-side angle here. So here's an example where I give you an angle of 48 degrees and then two sides not between. Those are not on the outside of those angles. I give you 5 and 4, and you can make an acute triangle or you can make an obtuse triangle over there to the right hand side. There's kind of two cases sometimes, all right, depending on what like the distances are and the angles are right there. So that is why in geometry we said, oh, if I give you two sides and an angle, that doesn't always make congruent triangles. So we're going to tie that in here. They kind of have a chart right here that kind of shows you how you can go and determine if there's going to be one triangle, two triangles, or sometimes it can't even close up and make a triangle at all. But instead of doing all that right there, I kind of got a little bit of a different process that we're going to do here. So I'm just going to show you through the examples that we have here today. So we're going to look here at this first one. So looking at it initially, they're just going to say, hey, I got a side of 15, got a side of 12, got a side of 94 degrees, right, or an angle of 94 degrees right there. We're not sure if that makes one, two, or multiple, or no triangles, I guess I should say. So what we'll do from here is sketch out just a generic triangle. I have no idea how big everything needs to be, so it's not going to be to scale. I'm going to go ahead and put A down here, B, and then C for your angles. And we know angle A is 94 degrees. I'm going to make that font a little bit smaller. And then we know side A is across from that, and that's going to be 15 right there. Side A is across from angle A. So A right here, that's 15. And then I guess we have across from B, we have the 8.2. Or I'm sorry, 8 point. Oh, I'm ahead of myself here. C was 12. Getting down to my notes. Okay, I kind of spoiled the surprise there. You're gonna have 8.2, I guess, at the bottom. So when you see this right here, we have an angle and we also have a side. So we're going to use law of sines to find the other angle here. I guess we're going to find angle C. So this will start out just like from yesterday. We'll go sine of 94 degrees. And then over 15, and then that'll equal sine of C, I guess, and we don't have C, and then over 12 right there. Okay, to solve a proportion, you need to cross multiply and divide, right? You'll do 15 times sine C, you'll do 12 times sine 94, and then we'll divide there after that. So let me grab my calculator app so I can do that. And actually, I'm just going to write it out here first. So this will be 12 sine 94 equals 15 sine C. And then what do you divide by? 15, good. Now, instead of typing that in right now here, I'm just going to kind of keep in mind what the process we need to do here after this here. So you're solving for an angle. So what we're going to do is we're going to hit the second button right there, second sign, that is sine inverse. And we're going to sine inverse that whole entire thing, 12 times sine of 94 degrees. Make sure you close that parentheses up, that it opens in your calculator. And then you can do divide by 15 like that. And that's exactly how I'm going to type it into the calculator. So just hit second sine, 12 sine 94, close parentheses, and then divide by 15 right here. All right, and that tells us our angle. A lot of times, more times than not, they'll tell us to round our angles to the nearest degree. Yep, angles to the nearest degree, so we'll round that up to 53 degrees. That's kind of how you go and find that side right there, 53 degrees. Okay. Now, after you find angle C, here's how you go and tell if there are multiple triangles or not. What I'm going to go and do off to the side is I'm going to go and do 180 minus 53 off to the side. and that comes out to 127. Okay, and then what I'm going to do here is I'm actually going to kind of just quickly resketch that triangle again. You can do like the same size, I guess. Copy and paste it here. Now here's the issue with this. This would be potentially the second case for angle C. I'm going to actually call it C, and then with a tick like that, like C prime, I guess. Kind of use that notation a little bit in geometry, I think. Now there's an issue with this angle right here. So notice here, if my second case for angle C is 127, I have 127 and 94. That's already bigger than 180 right there. So right here, this triangle, you can't have that case right there because all the angles are more than 180. So what does that mean in our case? There's only one triangle that's going to work out here. So if it adds to more than 180 with that second case, after you go and get your other angle, then you're going to go and say there's no second triangle. All right, it's just going to take a couple of examples to really kind of get down. I'll show you all the different variations there. But so once again, to recap how we get the 127, we took 180 minus 53. We got 127. We took the original angle we started with, 94. And 94 plus 127 is already bigger than 180, so you wouldn't have enough degrees to make your final angle. All right. Now that we kind of know there's only one triangle, we're going to go and find the last piece. The last thing we don't have for this triangle is side B and actually angle B. Now angle B should be easy to go and find. So I'll kind of section it off here. Angle B, what we're going to do for that is just go 180 minus 94 and then minus 53 as well. And this will be angle B. And you can either do the mental math or you can just use your calculator to subtract, and that gets me 33 degrees right there. And once you have 33 degrees, now you can use the law of sine one more time, and then to go find your final angle here. We'll go sine of 94 again, and then to 15, and then we'll say equals sine 33 to side B. And then once again, you will cross multiply and divide from there. 15 sine 33, and then equals B sine of 94. And most of y'all might even skip writing this step out here. That's fine if you do. So from there, just go divide both sides by sine of 94. (15 sine 33) close parentheses divide by sine 94. And there's that 8.2 that I accidentally wrote down earlier. Okay. And those are going to be your three things. A lot of times the triangles are going to give you three things to start with, and then you got to find the other three things. And then you also got to double check and make sure there's not a second triangle. So let me zoom out there and let y'all make sure you get all of that, I guess. Okay, any follow-up questions so far? Yeah. You want to see if there's a possibility of making that second triangle. So if you go back here to our picture, I had it pulled up earlier, like you went and basically, I think we found, like on this picture, we could go find angle B next. And the angle B can either be an acute or an obtuse angle. And to go get the second case angle, like over on the right side, you do 180 minus your original angle, and that's going to get that. And then the whole idea on this one is when we did 180 minus our angle C to find the alternate C right there, 127 plus our original 94, that was already bigger than 180 right there. So it couldn't possibly make a triangle there. So I think the third example we're going to see our second case triangle. So just kind of hold on here for a second and I'll kind of show you. But yeah, we'll always check on these side angle ones. We need to always check for a second triangle. This is the only type of triangle that you need to check for. So we're going to give it another go here on this one. Let's practice sketching it out here real quick. Why don't you guys try sketching here on your own before looking up here on the screen. Sketch kind of a generic triangle. If y'all want yours to match, I'm going to go A, B, C, kind of like that. And then go and label now your angle and then your two sides. I think on the homework they give you like A and angle C a lot. You don't need a whole lot of work here for this one. This one's going to be a kind of a shorter problem. Okay, so here's what kind of messes people up here. If you don't practice this a lot here, you're going to not learn to recognize this here. So when you go and set up here, we have we have 11 right there for side B. So now we can go find angle B here first. Using law of sine right there. So what I'm going to do is I'm going to go sine 61 and then over 9 and then equals sine of B and then over 11. Okay, and then when you cross multiply and then sine inverse, you're going to have 11 sine 61. That's because you're going to have to multiply those. And then equals 9 sine B, so basically you need to go back and divide by 9. And what's kind of weird when you type this in, watch what happens here. Sine inverse, 11 sine 61, and then divide by 9 like that. It gives you an error. Okay? And that's not because we did something wrong here. That's because the triangle could never close up and make a triangle. Based off of our angle, I guess that 9 up there at the top, it wouldn't be able to close up and ever make a triangle. And that's kind of the big idea there. So this one here, you get an error, and that means that there's no triangle possible at all. Like this thing would not close up and never make a triangle. I guess if you kind of want a good picture up there at the top, if you want to kind of go back up there, let me show you here real quick. Where is it? It's like this right here. Now, I think we had, yeah, which one was our shorter? Yeah, A was shorter there. So A is not long enough. Like you can try and rotate it to close up that triangle, but A would just not be long enough to ever make a triangle right there. And that's kind of what's going on there. That's why it's happening. What do you guys need to know? If you get an error, maybe just double check and make sure you didn't accidentally type it in incorrectly. And then if you did type it incorrectly, then that probably means there's no possible triangle right there. Okay. And just expect to see probably one of each on the test right there. Probably see one where it comes out to one triangle, one maybe where there's no triangle. And then let's see what's going on here. The next one here, we'll have 2 triangles possible. Everyone get all that there? All right, let's keep it going then. So, kind of write a little bit small here on this one. This one's going to have 2 triangles. Just looking at it initially, I would not even be able to tell if that's got 2 triangles. I'm going to do my little trick here, just labeling everything here. So, I'm just going to go and make a generic triangle here. A, B, C. Angle A is 43 degrees. Make sure you put in your degree symbols. That'll help you make sure you don't accidentally use it as a side. Side A across from angle A is 25 units long, and then side B is 28. So initially, nothing looks different here. And, we're just kind of drawing a generic triangle, like it's not going to be to scale here. And then now let's go and sketch this out here. Or, I'm sorry, write the law of sine there. So sine 43 to 25. And then this will equal, I guess, sine of B to 28. Okay, and then hopefully y'all are starting to kind of catch along here. What you actually type in this calculator, it's 28 times sine of 43, because those are across from each other. And then you would need to eventually divide by 25 right there. And then we're going to sine inverse that whole thing. And then see what we get. Oh, I got a bunch of stuff already there. Second sine. Apparently I got 49.8 degrees here. And let's go ahead and round that up now to 50 degrees. So that is angle B. But we need to go and double check our other possibility. Now I'm not going to draw it to scale here, so this isn't going to actually look good. But what I'm going to do now here is label these like with extra little tick marks here. So like you can put B with a tick mark up there, and then C with an extra little tick mark right there. Call them A and B and C prime right here. A actually is going to be the same. Okay, so now to get your second case, B, your B prime here, what you need to go and do is take your original B that you got and then subtract it from 180. So if you do 180 minus 50, does that get you 130, I think? And like I said, not to scale, but don't freak out there about that. But yeah, that'll be 130 up there. Now, if you go and add 43 and 130, that is not bigger than 180. Okay, and that's kind of the big idea here on this. So in this second triangle, when you go find the second C right here, you're going to go and do 180 minus 130 and then minus 43. If you were to try that on the first problem we did, you would have gotten a negative answer because they were already bigger than 180. These are a little bit smaller. So there will be like a leftover little angle here. It's not going to be very big. I think it's only, 7 degrees here. So that means that last angle here is 7 degrees. All right. Now, if you're going backwards here and looking at your first case, we can go get angle C. Y'all would have done that, anyways. To go find angle C here on the first one, the regular C, like the main C, I guess. You do 180 minus the 43, but then minus the 50 instead of the 130. And then that C comes out, whoops, and this is without a tick here. This is your main C. That comes out to 87. And that's how you get your two triangles. Now, there's one thing missing on both of our two cases of our triangles here. I don't think we have side C, but now that we got our different angle C's, now for side C, we can go and use law of sine again. I'm going to go sine of 43 over 25, and then equals sine 87, and then over C right there. Zoom in there so that's not so super distorted there. Sine 43 over 25 and then equals sine 87 over C there. And then guys, y'all just cross multiply and then divide here again. This would be 25 times sine of 87, and then I guess you would divide by sine of 43. And side C for the first case, 36.6. And those are your three missing attributes there for the first case right there. Okay, now we'll go do the same exact thing on the second case triangle with our C prime angle right here, the 7 degrees here. So let's go and try it out here. It'll look pretty similar here. It'll be sine of 43. I forgot to label the side across here, but you need the 25, I guess. And then, the 25 and 28, I guess. So sine 43 over 25. And then remember, we're trying to find the new C. So then you'll go sine of angle C, which is 7. And then over, you could do like C prime like that. Or you could just write it as C. I might get confused and think that's a power of 1 or something. And then just cross multiply and divide again. Your second C side right here, that should be 25 sine of 7, and then divide by sine of 43. 2.6, actually 2.7 after you round up. Say what? Oh, instead of 25, yep, good call. Oh, see, that's the nice thing about recording this live here is you can catch my mistakes earlier. Is that what y'all got there? 4.5, I guess. Okay, sweet. Yeah, 4.5 after rounding up. So like on the tests and quizzes, I'm not gonna actually I'm gonna have just like 3 blanks, and sometimes they're gonna have like 2 C's, 2 B's, and then 2 side C's. So I'm not really going to tell you specifically if there's 2 cases or not. So you just gotta test them out each time, and you'll get plenty of practice of that tonight in the homework. So let's try out one more here, and then see if it's got 1 case, 2 cases, or no case at all. And then we just got an application problem there after that. Okay, let's give it a spin here. What do we do first? Yeah, make a triangle. You know what I would honestly do too? Go ahead and just make 2 triangles just to begin with. Just gonna have 2 drawn out. And they should have the same exact thing. 26 degrees for A. Here, I'll do it like this. A, B, C. A, B, C. Okay, and then A, side A is 5, side B is 9. So those will be the same on both cases right here. How do we find angle B first? Law of what? Law of sines. Here, I'll keep it the same color. That'll be sine of 26 to 5, and then sine of B, and then to 9, I guess. Okay, and then you will cross multiply, and when you're finding an angle, sine inverse there. So it'll be 9, or actually, hang on, sine inverse. I don't like to store decimals and write down things, so sine inverse, and then 9 sine 26, and then we would go back and divide by 5. I guess I'll write it out here for the notes. You don't need to write this out, I guess. I trust that you guys can do that there. So about what, 52 degrees right there? Okay. So to find the second case B, what do you need to do with 50? Or 52, I'm sorry. Subtract it from 180. So we'll do that there. 180 minus 52. I guess that mental math's not hard. 128. This is your second case here for B prime. Okay. Then ask yourselves if 128 and 26, if you add them together, are they bigger than 180? Yes or no? No, it's 154 right here. So you have enough room to make a second angle right there. Or to find, I guess, the last angle, I should say. Yeah, just find your last angle, C prime. Just do 180 minus 128 minus 26. Or you can add them up first and then subtract from 180. However you want to do it. And that comes out to, oh, did that come out to 26 there? Okay. Interesting. Actually, fun little tidbit here. What if those are both 26 there from geometry? Do y'all remember what type of triangle that is? It's actually isosceles, yeah. Which actually, then you could probably take a wild guess in our second case triangle what the last side is. Any ideas? It's going to be the same as this side right here. It should both be 5 right here. Okay, here's the math behind it. You'd go sine of 26 to 5, like the ones you have there. And then I guess we need side C, and that's across from the other 26. So, I mean, honestly, if you just use logic here, like side C, the only thing it could be is 5. And you can go cross multiply and do all that stuff. 6 sine 26 divide by, oh, not 6. It's a C there. Okay, so actually 5 sine 26, and then divide by sine of 26. And notice you get 5. And that's because there's isosceles there. Kind of a special case there. All right, let's see over here. I guess I kind of forgot to go get everything else here. We need to go and find, we have our B angle. I guess we need to go find our C angle here. So we'll go back here. 180 minus 26, and then minus 52. Here, let me zoom out just so y'all can get all that. So 180 minus 26, and then minus the 52 that we got. That comes out to 102. Obviously not to scale. The picture just kind of helps us get started here on this. And then I guess for side C, you can go and do law of sine again. So you will use law of sine quite a bit today. You'll do sine of 26 over 5 equals sine of 102 to C. And then C will just be 5 sine 102 divided by sine of 26. And if you're comfortable just going straight to your answer from that, you can. So 5 sine 102. Enter. C is 11.2. Okay, so you should have 6 total things here. You should have 2 angles and then a side for each of those. And that'll be it there. Let me zoom out and make sure you get all that there. So that's another 2-case triangle right there. All right. Got one more here that we're going to look at, and this will be it here for today. Kind of short. So this one's already kind of drawn. I think maybe on a future assessment you might need to draw something like this yourself. Maybe we give you a picture, I'm not sure. But I guess downtown is located due north of a straight segment of a train track oriented in an east-west direction. So I guess this right here, this bottom side of this triangle is your train track. And then just north of your train track, I guess is going to be your city here, or downtown. So a passenger on a train traveling west to east notes that downtown is visible at an angle of 41 degrees to the left of the track there. I guess I don't know if they just brought a device to measure that on the train with them, but apparently 41 degrees right there. And that's already kind of drawn, so I guess the train's kind of going that way, 41 degrees at some point in time right there. Okay, and then after traveling 8 kilometers, the passenger notes that the angle now is 47.5 degrees. So estimate the vertical distance from the track to downtown to the nearest kilometer here. So basically they're saying like that shortest distance from the train tracks, like here's your train tracks here, that shortest distance to downtown right there, that's what you're trying to find right there. So I'm going to put X right there. I'm going to erase all this extra junk here that we don't need. Okay, so here's what I would do on this here, because here's the issue. If you just look at this triangle and you say, oh, try to use like SOHCAHTOA or something, it's a right triangle. We don't have any side links to that triangle, which is kind of the issue. So here's what I'm going to do instead. What I'm going to do instead, and there's a few different ways you can do this. The way I usually will do this here is I'm going to find this side right here. We'll call it Y for a second. Okay. Now, before we can find side Y of this obtuse triangle here, what I need to do is go find a couple of angles. And here's a couple of convenient things here. 2 angles that make a straight line in geometry add up to how many degrees? 180. So we're going to go 180 minus the 47.5. That's the first thing we're going to do there. Apparently I got 132.5 for that angle. And then now you got 2 angles inside of that triangle. To find the final angle in that triangle, I'm going to go and do 180 and then minus 41 and minus the 132.5. And apparently I do that and you get 6.5 degrees right there, kind of a small angle there. Okay, and we're going to find side Y. What is side Y across from? What angle? It's the 41 degrees right there. Okay, and then we're going to use the 8 kilometers. What is the 8 kilometers across from? The 6.5. So we're going to go sine of 6.5 degrees to 8 kilometers, and then equals, I guess, sine of 41 to Y. All right. And then that's just law of sine. We'll just cross multiply and divide there. And that's going to come out, I'm just going to type it here to the side, 8 sine 41, and divide by sine 6.5. 46 point. They want us to round to the nearest kilometer. I'm going to go like 2 decimals just for now, and then we'll round it off here. So 46 point, let's call that 36 there. That's your y distance. That's not degrees there. Okay, then after you get that, then from here, a couple of options. You can actually use law of sine again if you want to find x. You could actually just use just regular SOHCAHTOA to go and find it, since that should be perpendicular right there. And that's usually what I would do, but you can still do like law of sine with 90 degrees, and it would still kind of work out. So 2 approaches you can go from here. Like I said, I'm going to go and use this here, and I'm going to say this is the opposite, this is the adjacent, this is the hypotenuse, and just good old-fashioned trig right there. We'll go. We need to use O and H. That would use the sine function. You can say sine of 47.5 degrees, and then equals x, and then over 46.36. And then just multiply sine of 47.5, multiply that times your 46.36 there. And that'll get you 34.18. So I guess 34 kilometers. Right there. And that matches up my notes right there. Now, like I was saying, you could also just say, hey, this is 90 degrees right here, and you can go sine of 90 over 46.36, yeah, and then equals sine of 47.5, and then over x, and you should get the same thing. And that'll be it there. Put a star next to that one. That one is a good one to come back and maybe try on your own.